So if you ever grappled with the question of how are our streaming data services working or what is life, that's what Streamdal does. They're a streaming data performance monitoring solution for event-driven systems, and I'm going to pass it over to Ustin to tell us all a little bit more about what they do.
All right, thanks Kelly, and thank you Workbench and everyone else for having me. So my name is Ustin. I'm the CEO and co-founder of a company called Streamdal. And today I'm here to talk to you about monitoring beyond metrics, particularly inside streaming data and technologies like Kafka, RabbitMQ, or any kind of pub/sub related thing that you have going for you. All right, so a little bit more about me. I'm a physicist turned computer scientist. Most of my physics career I spent doing a lot of research in nanofabrication of chemical sensors, and particularly like around all sorts of related materials like gold and platinum. It was, I don't know, kind of boring. I went into computer science where I was doing a PhD, particularly in distributed storage over lossy networks, and spent a lot of time in streaming and asynchronous flows. Particularly is like one of the reasons we decided to build Streamdal is because we saw this problem across many different spaces, and we have experience in building it. And so our goals are, we want to define a new category of APM, which is streaming data performance monitoring. And what we want to do with that is take real-time data, be able to monitor it, and detect any anomalies that are happening before they hit your database and before there's data at rest. So let's go into more of the modern world. You know, we all like to build really scalable companies that have a lot of data. You know, we're moving from batching systems to real-time systems. And unfortunately, a lot of these systems come with very new challenges. Usually outages are longer to debug, and there's higher churn in engineering because these are very complicated things. So this is where traditional sort of approaches start to really decay. So let's look at APM and metrics. I love APM. My co-founders from New Relic, we use Datadog internally. But unfortunately, if you want to monitor something like Kafka and figure out exactly what went wrong, it can only tell you, hey, this is how much RAM it's using, this is how much CPU it's using, this is how much disk space it's using, et cetera. But unfortunately, it doesn't tell you why something broke. It just tells you how it broke. And to give you an example, there's a really big company, I'm sure we all have used it. It's in version control that a while ago had an outage. And the outage occurred because they had Kafka. Not only that, they were encoding their data for performance in something like protobuf. So it was just ones and zeros flowing in. And it was a very poor encoding, so a lot of their downstream services said, hey, I know this payload, but the data is not correct. I don't know what to do with it. Let me go ahead and retry it. They keep submitting events into Kafka over and over again, and eventually, boom, crashed, and all services dead. So you don't want to do that. You want to do something else. So logs are also not actionable because they're made by developers for developers, and they don't really have any organizational benefit except say, hey, this is what happened, something broke, here's a really quick log of what might have went wrong. And they also cost a lot of money at scale. So what most people do is they resort to building this in-house. I've done it many times, my co-founder's done it many times, and so have all of my team members. And unfortunately, that comes at a really high cost. Good engineers are scarce, and what you're doing is forcing them to build this, and then all they're doing is babysitting versus working on your product. And that kind of sucks and is going to cause higher churn. I've seen it. Don't do that. So we decided we wanted to build a generic solution that we just got tired of building internally at every company we worked at. And it works really simply. We have an open source agent called Plumber. It's kind of like a polite consumer. And what it does is it hooks into any data stream, whether it's Kafka, GCP pub/sub, Kinesis, anything like CDC, even for databases, which is change data capture, changes in your database. It indexes all of that data, visualizes it for you, and also will discover and manage a schema automatically. And in addition to that, it can detect any anomalies in real time, like PII. Maybe you want to filter on certain data. It also integrates with all of your favorite tools, and if we don't have an integration, we can build one tomorrow. In addition, we also provide like an ETL-ish layer where we have WASM transformations in real time on top of your data, whether it's on ingest or output. And we also have a concept of smart dead letter queues, and you can think about it as like data in escrow that we decided was bad, and we held it for you and waiting for you to fix it. So on that note, let me quickly get out of here and go to a really quick demo. So right now, I kind of have a lot of things pre-made because of time constraints. So this is a collection, is what you would see when you create one. And the collection is a logical unit of a Kafka topic or just any source of data and ingest data. And so basically, we see here that we have a ton of basic metrics like how many events, what sizes, and we also have all your events here. So think about this, like this is actually protobuf data being sent. So this data is encoded, it's completely invisible, ones and zeros, and here it is, looks like actual JSON that you can quickly search and look through. So let me show you this. So here's an event, it has some billing data, here's like an order ID, so I want to go ahead and search for it. Well, here it is. It's displayed out of like millions of events that you will have going through your system. So on that note, let me just show you really quickly what monitors look like. I have written a really quick script just to show you. So for instance, if we go back here, we see that this order data, or sorry, this product data has a price, and that price is 0. And maybe this is something we're looking for. In the real-time world and given the new bank run, maybe we want to know that price is 0 right now, right? And we want to be alerted on that because that's really important to us. So I'm going to go ahead and send an event out. And I have a monitor set up that will alert me in Slack that, hey, we just detected an event where the price is 0. So if you go to our Slack, we see that I've created a channel for this community. Here it is. Here's my event where the value is 0. Note why this is important. So one of our biggest customers is Recharge Payments, and they do all subscription-based billing for Shopify. For them, it is really critically important that they understand how much a subscription is, if they've missed a subscription, and if maybe the schema of that subscription changed. And let's dive into dead letter, and I can kind of elaborate on what I mean further. So we have this concept of a smart dead letter queue. You can think about it as preemptive action on your event bus so that I can extract bad data before it hits any of your services or your databases, and basically any source of truth that you have. So I'm going to go ahead and pipe an event in our, let's see here, I call it schema. So in our ingest over here, we have an event that has a type and it just has 1. It is a number, it is an integer, it is not a string or anything like that. So if you pipe an event where its type is something else like foo and it's a string, your services are going to break because they're like, hey, I don't know what this is. It kind of looks similar, but the data is wrong, and I don't know what to do with it. And so in this case, what ends up happening is we have this dead letter system. As you can see, we pipe something in right here. It says dead letter. And we look here, and we see that here's an event. And for someone like Recharge or anyone that is consuming third-party APIs, those APIs can change, and you can have an outage. And you want to prevent that from ever happening. And this is how you would do it. You would monitor all these events. You would monitor for schema changes. Well, you would then be notified that a schema change occurred and something broke. And so you'd want to see this event. And this is kind of like what I was talking about, data escrow, right? Because we're holding that event for you because we don't want you to miss important customer events like subscriptions being created. You're losing revenue. And so here I am staging this event, right? And so what's basically going to happen is, any minute now, here we go. We see here and it says it's not replayable. And so I'm going to go ahead and edit this really quickly, and I'll edit this to be like, I don't know, 1, 2, 3, 4, 5. Okay? Let me remove the string over here, and let me also go ahead and search for this request to show you that this is actually a real thing. So I'm going to hit save. I'm going to go ahead and select it, and I'm going to replay the selected message. I'll just call it something else, and I'll select the collection that I've created. And there it goes. So it has officially replayed that message, and what it's doing is you can replay this data to anything, any service, a database, really the sky's the limit. And because we allow WASM transforms, you can really write functions to even filter data while it's being replayed. So I'm going to quickly go ahead and go over here. I'm going to search for that ID, and we see event 123, and it's been redone from foo to 1, 2, 3, 4, 5. Okay, and that basically concludes the demo and our platform. And so I just want to point out, like, some of the benefits that we have is that we helped Recharge improve their MTTR by 90%, and their outages went from 3 hours to 15 minutes. In addition, we also help companies like Park Mobile to see that data, and their SREs are going from 0 to hero because they know exactly what those outages are and the problems that are occurring. And that's it. So thank you very much. We just launched last week, so if you want to come nerd out with me about this, let me know.
Awesome. Thank you, Ustin. So we do have time for a couple of two questions. If anybody in the audience has a question for Ustin.
Go ahead.
The dead letter feature, is that what it's called?
Yeah.
Dead letter? Have you done any latency testing on when you introduce that? And I assume it's blocking into the database, right?
So you're asking if there's any latency related things. So most of the dead letter, like, our customers are piping them back into like Kafka and not a database. But if you wanted to introduce like a little back pressure, then you can simply write a wasm function to do that yourself. And that way you can control the latency a little bit. But for our use case, we're more on the high throughput end. So does that answer your question a little bit, or?
I just don't know what a wasm function is.
Oh, sorry, that's WebAssembly. And so basically you can write a function in like JavaScript or Go or Python or Rust, and it will compile natively into our system, so it doesn't like bleed any of our credentials, and we're calling it locally.
And one more question over there.
Hey.
Do you think there's a need to be mobile first? You have a mobile app?
So the question is, do I think there should be a mobile app? I don't know. I guess, does Datadog have a mobile app? Yeah, maybe. I don't know. I haven't thought about it. We're, like I said, we just launched last month, so yeah. Any other questions?
Any others? All right. Well, with that, Ustin, thank you so much.
Thank you, everyone.